Welcome, Hornets, and thank you for joining me today. This is part 3 of assignment number 5, working with u-substitutions. We're going to be starting in number 55 and then take a look at 57 before we skip off to number 61 and 63 and see use of u-substitution in a few other different ways. All right, so starting off with this is a continuation with what we were doing in part 2. And we're just trying to set this up as dy equaling the integration of sine of 1 over x over 2 dx. And I'm just going to set that up. Now, I'm not going to worry too much about going through all 3 of my initial steps. I do have 2 of them. I would have taken an extra step and done the integration below it, but I'm not going to worry about it here. Instead, what I'd like to do is just get my y equals negative integration. If u equals x over 2, du is 1/2 dx. We do not see a 2 or 1/2, so I'm going to put 2 du equals the dx, and a 2 now goes in front. I have sine of u du, and we know that this is going to be a negative cosine. Therefore, I have y equals negative 2 negative cosine of my u, which is x over 2 plus c, double negative. I'm getting 2 cosine x over 2 plus c equals y. Now, this is where we use the point. I know that my y is giving me a 6, and it should be 2 cosine of 0 plus c. Now we know that the cosine of 0 is 1, so we're subtracting 2, and 4 has to equal c. Y equals 2 cosine of x over 2 plus 4 is my answer. We're now going to move to 57. 57, once again, trying to find the particular solution. We are given f prime of x is equal to 2e to the negative x over 4 power, and we are being told that we have a 0, 1. So, once again, let's call this dy equals 2e to the negative x over 4 dx. You'll notice I'm doing all 3 of my initial steps this time just to make sure that people recognize. And now I'm using my u equaling the power negative x over 4 du is equal to negative 1/4 dx, and I'm going to move the negative 4 to the other side. I now have my y equaling, this is now giving me negative 8, the integration e to the u du. I then have y equaling negative 8 e to the negative x over 4 plus c. We plug in our point. 1 equals negative 8 times e to the 0 power plus c. 1 plus 8 equals c. And I now know my equation is y equals negative 8 e to the negative x over 4 plus 9. And there's my solution. Alrighty, we're now going to skip off to the next group of problems, number 61. Now, this is actually a very important part of u-substitutions, and that's called changing my variable. Sometimes our situation is not structured in a way that we can do it at all. Look at this problem here. Notice in this problem that I cannot distribute that x. So we have to try to find a better way. This is called changing your variable. If I let u equal x plus 6, then I know that u minus 6 is equal to the x. And I can now replace u and have the square root of u, and in place of the x out in front, call it u minus 6. Well, be careful. We still have to find what our du is equal to. Luckily, du is equal to dx. We can see that right here. And I've got my du. Sometimes it does change, and we have to be careful. Now, please take note. In this, there were three different pieces that I had to replace. I had to replace dx with du. I had to replace the x plus 6 with u, and I had to replace the x with the u minus 6. If this were a definite integral, I'd also have to change my endpoints. Let's go ahead and finish this up, because we're not done yet. We're now going to change our u to the square root into u to the 1/2 power, and we're going to distribute it. This gives me u to the 3/2 minus 6u to the 1/2 du. I can now do my integration. This is giving me 2/5 u to the 5/3 minus 6 times 2/3 power u to the 3/2 plus c 2/5. I'm now putting in my x plus 6. This is called back substitution. I have reducing 4. I'm now putting x plus 6 in here. 3/2 plus c. That's my goal. That's what we want. Woo! Let's go ahead and try number 63. Once again, that was 61 for those of you who are keeping track. We're now going to take a look at number 63. 63, very similar. We have x squared square root. We have 1 minus x dx. We're going to change our variable, so we're letting u equal 1 minus x. du is then negative dx, and we'll have to change that to negative du equals the dx. We can clearly see that our x is going to equal 1 minus u, and that's what I'm going to use. 1 minus u squared, square root of u, negative integration du. See the three parts that I've substituted? I substituted the dx with the negative du. I replaced 1 minus x with u, and I replaced the x with 1 minus u. Now, in order for us to continue with this, we have to FOIL it out. We sometimes just have to put up with having to do things that we just don't enjoy too much. But it's just busy work, so we're just going to keep going. U, this is really 5/2 minus 2u to the 3/2 plus 1u to the 1/2. This is then du. Now I can simplify it. It's negative 2/7 u to the 7/2 plus, this is giving me 4/5 u to the 5/2 plus 2/3 u to the 3/2 plus c, and we simplify by back substituting our 1 minus x. Once again, the more you do this, the easier it gets. You have to understand that. This is why you practice. A lot of people did not want to practice at the end of the last semester because I wasn't putting the answer key up. But I gave you access to all of the answers in class, at lunch, or after school. You just had to come in and get it. Please, do a little work here. All right? Now, the last section that we have in this, and this is the last thing that I have for our assignment number 3. There are lots of little other places to work. For example, even and odd functions. How do we double values and then go from 0 to the endpoints? Come in, check your work with the information that I've got. My answer keys, please. I really want you to be able to do the work. Alrighty, so here we go. We're now looking at the integration from -1 to 1, and I have x squared plus 1 the quantity cubed dx. We're now looking at a definite integral in number 69. Everything is going to be the same. U equals 2x, u equals x squared plus 1. Du is therefore going to be 2x dx. There is no 2. 1/2 du equals the x dx. We're now able to substitute. Now, be aware that my values are changing into u's, aren't they? They're no longer x's. I have a du now, and I have a u cubed. That means that where I had x equaling -1, it's now -1 squared plus 1, which is 2. And then, oh my goodness me, if I put this in and I make it a 2, it's 2 to 2. Well, that very well may mean that this is 0. So instead of doing this, I'm going to have to back substitute. All right? Be aware of that. We very well may just get 0, but I'm going to back substitute. 1/2 times 1/4, u to the 4th power. It's even from -1 to 1. It is going to be 0. We can see that, but I'm going to go through all of the motions just so that you can tell. Plugging in the 1, I have then 1/8 being multiplied by, let's just go ahead and do it that way, 1 minus 1 minus 1 minus 1, and I'm looking at 1/8. 0 minus 0 is 0. So it was 0. Once again, we could see it. Had we done our substitution, I always am worried. I always think I'm going to do something silly. And in this case, it wouldn't have mattered. Let's go ahead and take a look at number 71. 71. Here we go. 71 gives me the integration from 1 to 2. I have 2x squared square root x cubed plus 1 dx. So I can clearly see my u substitution. U is x cubed plus 1. Du is the 3x squared dx. And I'm going to make this 1/3 du x squared dx. Now some people are saying, what about that 2? Well, that 2 comes out in front. Now, I have that option. Let's go ahead and replace. Let's just change those values. Plugging in the 1, that's going to give me a 2. Plugging in the 2 goes to a 9. Square root of u du. I now have 2/3, and that's multiplied. That's a 1/2. So it becomes 2/3 u to the 3/2 power from 2 to 9. 4/9. I then have 9 to the 3/2 power minus 4/9 of 2. 3/2. Notice that's going to give me 8/9 root 2. And this is going to give me 3/27, 12. And I get 12 minus 8 root 2/9. Alrighty, Hornets. Please continue working on these. I hope that if you are finding yourselves having difficulty, that you come in and get additional help. Remember, if you found this helpful, please click like so that I know so. Thank you very much. Please take care, be kind to each other, and remember, change starts from within. Bye-bye, everybody. Thank you, Hornets.